Right now, beneath one of the most visited national parks on Earth, something is moving. Not slowly, not gently. The ground at Yellowstone rises and falls by inches every year, pushed upward by a force so vast, so ancient, that most people never stop to think about what it actually is. Because Yellowstone is not just a park. It is not just geysers and hot springs and wandering bison. It is a supervolcano, one of the most powerful geological features on the entire planet, sitting directly beneath the continental United States. And the question that scientists quietly return to, year after year, is not whether it will erupt again. It is, when. To understand Yellowstone, you have to forget everything you think a volcano looks like. There is no cone, no mountain with a smoldering peak. Instead, what sits beneath Wyoming is a caldera, a vast, collapsed crater, nearly 45 miles wide and 30 miles across, formed not by a single eruption, but by the catastrophic collapse of the land itself, after so much magma escaped from below that nothing was left to hold the surface up. Beneath that caldera, there is a magma chamber. Two of them, in fact. The upper chamber alone contains enough molten and semi-molten rock to fill the Grand Canyon, more than 11 times over. The heat driving all of this comes from a hotspot, a fixed point deep in the Earth's mantle where superheated plumes of material rise toward the surface. The North American tectonic plate moves slowly over it, like a piece of paper sliding over a blowtorch. And every few 100,000 years, that blowtorch reminds the world it is still there. Yellowstone has done this before. 3 times, in fact, and each time it reshaped the continent. The first supereruption, 2.1 million years ago. It released more than 600 cubic miles of material into the atmosphere. To put that in perspective, the eruption of Mount St. Helens in 1980 released less than 1 cubic mile. Yellowstone's first eruption was 600 times larger. The second, 1.3 million years ago. Smaller, but still staggering. Enough ash to bury entire mountain ranges under dozens of feet of grey, suffocating debris. And the third, 640,000 years ago. This is the one scientists study most closely. It created the caldera we can see today. It sent ash across virtually the entire United States, as far east as the Gulf of Mexico, as far west as the Pacific coast. 640,000 years ago. Which means, if these eruptions follow any kind of pattern, the next one is already overdue. The United States Geological Survey monitors Yellowstone around the clock. More than 2,000 earthquakes occur there every year, most of them too small to feel. But the instruments feel them. Every tremor, every shift in ground temperature, every millimeter of uplift is logged, analyzed, and compared against decades of data. What they have found is that the ground at Yellowstone is alive in ways that continue to surprise researchers. Between 2004 and 2008, a section of the caldera floor rose by almost 10 inches, the fastest rate of ground deformation ever recorded there. It then subsided, and then rose again. In recent years, scientists have also revised their understanding of how quickly a supereruption could be triggered. Earlier models suggested it would take centuries of warning signs, but newer research, based on mineral records trapped in ancient rock, suggests the system could reach a critical point in a matter of decades, perhaps even years. The official position remains that an eruption in our lifetime is unlikely, but the word scientists consistently avoid is impossible. If Yellowstone erupts at full supereruption scale, the first thing to go would be the ground itself. The initial blast, driven by superheated steam and magmatic gases, would be powerful enough to collapse buildings hundreds of miles away. A column of ash and debris would rise into the stratosphere within minutes, reaching heights of up to 30 miles. The sky in Wyoming, Montana, Idaho would go black in the middle of the day. Within hours, pyroclastic flows would race outward from the caldera. rivers of superheated gas, ash, and rock moving faster than a hurricane, incinerating everything within 100 miles. There would be no outrunning them, no surviving them. By the end of the first day, roads would be impassable. Communications would be severed. Airports across the western United States would be closed, their engines destroyed by ash particles finer than glass. And by the end of 72 hours, the immediate death toll in the surrounding region would be measured not in thousands, but in hundreds of thousands. What most people don't realize is that the immediate destruction, as catastrophic as it would be, is not the greatest threat Yellowstone poses. The ashes, a full supereruption, would deposit volcanic ash across the entire continental United States. States closest to Yellowstone, Wyoming, Montana, Idaho, Colorado, could receive feet of ash, not inches, feet, enough to collapse buildings, enough to contaminate every water source, enough to make the land, for years to come, completely uninhabitable. Further away, the ash becomes thinner, but even an inch of volcanic ash is enough to destroy crops, to clog engines, to make breathing without a respirator a serious medical risk. Fine ash particles lacerate lung tissue. They carry toxic compounds, and once inhaled, the damage is permanent. Wind patterns would carry ash eastward across the country. Within days, the entire United States would be affected. Within weeks, ash and aerosols would begin circling the globe. The eruption itself would last days. The consequences would last years. Yellowstone would inject vast quantities of sulfur dioxide into the stratosphere. There, it would react with water vapor to form a reflective aerosol layer, acting like a planetary sunshade. Sunlight reaching the Earth's surface would be reduced. Temperatures would fall. Scientists estimate a global average temperature drop of somewhere between 5 and 15 degrees Celsius, sustained for years, perhaps a decade. That is not a cold winter. That is the end of agriculture across most of the northern hemisphere. Crops that took thousands of years to develop would fail simultaneously. Food systems that currently feed billions of people would collapse within months. Famine on a global scale, the kind that no aid network, no government, no international body could meaningfully address. The death toll from the eruption itself would be devastating, but the death toll from what follows, from starvation, from collapse, from the cascading failure of every system that modern civilization depends upon, would be incomprehensible. Yellowstone is not just a geological event waiting to happen. It is the closest thing our planet has to a reset button. If you found this unsettling, good. That means you're paying attention. The world beneath our feet is far more volatile than most of us ever consider. And the science of understanding it, predicting it, and one day perhaps even preparing for it, is some of the most important work happening on the planet right now. If you want to keep exploring the science that actually matters, subscribe. New videos every week. And if you want to go deeper on any of the topics we have covered, the links are waiting for you below. We'll see you in the next one.